Today's objective is to be able to classify numbers as either rational or irrational. So we're going to be given numbers, and our job is to figure out into which of these two categories does it fall. Now, when we talk about rational, there's one word that you should be able to recognize in that word. When we see the word rational, I see the word ratio. Okay? And now, in earlier grades, we learned different ways that we can write ratios. We learned to write ratios maybe using words. So, for example, maybe the ratio of girls to boys in a class is 1 to 4. Okay, so we can write that in words. We can also use colons to write it down. So I can say the ratio is 1 to 4. And then the other way that we learned to write ratios before was using a fraction. So 1 over, not 1 over 2. 1 over 4. Today we're going to focus on this way, okay? We're going to focus on the relationship between ratios and fractions. So we're going to use fractions to be able to identify whether a number or an expression, the value of an expression, is either rational or irrational. Now, rational numbers are numbers that can be expressed as the ratio of two integers. Now, what in the world does that mean? In simpler terms, rational numbers, they are numbers that can be written as a fraction. So any number that you can take and write it as a fraction is a rational number. So we have the example of 1/4, right? 1/4 is already a fraction, so I know that that is a rational number. We have, for example, 0.25. 0.25 is a decimal, but I know that that decimal can be converted into 1/4, so that's a fraction. And we have other types of numbers that we can identify as rational, and we're going to talk about those in just a minute. Now, irrational numbers are just the total opposite. They are numbers that cannot be written or expressed as a fraction. And numbers can only be one or the other, okay? You can either write it as a fraction or you can't. It's either rational or irrational. It cannot be both. So how can we tell if any number is rational or irrational? Well, the one thing is we know rational numbers have to be able to be written as a fraction. That's for sure. So if I have a number and it's written as a fraction, I know automatically that's a rational number because it has the word ratio in it, which means it can be written as a fraction. I know that any whole number, whether it's positive or negative, is always going to be rational. Because if I have a whole number, for example, the number 6, in order to write it as a fraction, there is one thing that you can always do in order to write a whole number as a fraction. And that's always put a 1 under it. Okay, so any whole number, whether it's positive or negative, is always going to be rational. Because all you have to do is put a 1 under it and automatically is a fraction. Now, decimals is where it gets a little tricky. We have two types of decimals. We have decimals that are terminating and decimals that are not terminating. Now, to terminate means to end. Okay, so if a decimal has an ending, it has a stop to it, it's automatically rational. So for example, the example that I used above, 0.25, it had a stop to it. It didn't have any other numbers after the 5. That's a terminating decimal. That decimal ended. Any terminating decimal will always be rational. Any decimal that has an end to it will always be rational. And now, what about if the decimal does not end? What if it's a decimal that goes on forever? Well, it depends. If the decimal goes on forever, but it's a repeating decimal, or it has a pattern, then that decimal can be turned into a fraction, and it means that it's actually rational. So for example, if I see something like this, 0.2 with a bar on top, well, I know that's 0.2222222 and it goes on forever, but because it's repeating, it's a repeating decimal, then I know that, and it can also be written like this, I know that 0.2 with a bar on top, or 0.22222, is rational because it's repeating. It repeats the same number over and over again. Okay, there is a pattern. Any decimal with a pattern is rational. So if I had, maybe it's not just one number, maybe let's say 645, 645, and it just repeats 645 over and over and over again, I know that decimal is rational because even though it goes on forever, it's going on forever with a pattern and repeating the same numbers over and over again. So how can we tell if it's irrational? Well, if it's a number that can be written as a fraction, and I'll show you how to check that in just a few moments, then it's automatically irrational. Also, if it's a decimal that goes on forever, but it doesn't have a pattern, then it's automatically irrational. So if I have something like, for example, let's say I have 0.645, but then it has 734, maybe 645 again, but 1, 2, 3 here, and it just goes on forever with three little dots. Remember, those 3 little dots means that the decimal goes on forever. There's no pattern here, because even though I see these same numbers here, there's nothing that repeats over and over again. So this decimal is irrational. Anytime you see a decimal that has no pattern and it goes on forever, that number is automatically irrational. And there are certain numbers that are famous for being irrational, like pi. Some people think that pi is just 3.14, but there's actually an infinite amount of numbers in pi. It goes on forever with no pattern. So pi is a famous irrational number. Another famous irrational number that a lot of people like to use as an example is the square root of 2. So using these descriptions of what rational and irrational numbers look like, go ahead and try to figure out whether these numbers are rational or irrational. The first one we're going to do is 0.5. Is 0.5 rational or irrational? 0.5 is rational. And it's rational because we should recognize that 0.5 is actually equivalent to 1/2. So automatically I can write that decimal as a fraction. Also, 0.5 is a terminating decimal. It has an end to it, so I automatically know that that is also a rational number. So we can say it's rational because it can be written as a fraction, or it's rational because it's a terminating decimal. Okay, so I'm just going to write here is terminating, and it's also a fraction. Okay? Now what about the number 8? Is the number 8 rational or irrational? 8 is a rational number. And it's a rational number because, as I mentioned earlier, any whole number can just be simply written over 1, and it's automatically a fraction. And anything that can be written as a fraction is automatically rational. Now what about this crazy decimal here? Is this decimal rational or irrational? Well, it's a little tricky because I see that there's a couple of repeating 4s and there's a couple of repeating 0s, but this decimal, 1 goes on forever, so we have to check, does it have a pattern? If it has a pattern, then it's rational. If it doesn't, then it's not rational. Well, here I see that first I have 400, then I have 40, 44, so there's really no pattern that I can follow here. So this number is actually irrational. And now I'm going to show you, okay, how do we use our calculator to figure out if crazy decimals like this, maybe I don't recognize whether it has a pattern or not, can actually be written as a fraction. On your calculator, there's actually a great function that you guys should have played around with during the scavenger hunt that helps you turn any decimal that is rational, any decimal that can be written as a fraction, your calculator will convert it for you. So how do we do that? Let's do the example that we have here. We have the square root of 3. And we want to figure out, is the square root of 3 rational or irrational? Well, we're going to go to our calculator and we're going to follow the 4 steps that I have here. So now we're going to learn to use our calculator to check whether a number can be converted into a fraction or not. So in my calculator, the first thing I'm going to do is put in the number or the expression that is given to me and figure out its value. In this case, we're going to start by putting in the square root of 3. So I'm going to go to second, I'm going to press x squared, and I'm going to get the square root symbol and put a 3 in it. When I press enter, it's going to give me this decimal. But I can't say this decimal is rational or irrational just based on what I see on the screen, because the screen won't give me all the numbers in a decimal if it's a decimal that goes on forever without a pattern. So I can't just tell by looking at this decimal whether it's rational or irrational. So what we're going to do is, once you get the value of what you're trying to figure out, it's rational or irrational, then you want to go ahead and press math. You don't have to rewrite that number. Okay, the calculator already knows that you're working with your answer. So all you have to do is click math right after you press enter and you evaluated it. Then you want to click the first option which says convert to fraction. Okay, so now it's taking your answer and it's converting it into a fraction. That's what your screen says so far. Now when I press enter, now you see that I get the same exact decimal back. And that's because the square root of 3 has an irrational value. When the calculator tried to turn it into a fraction, it couldn't find an equivalent fraction, so it gave you the same decimal back. So anytime you put in a number into the calculator, any decimal, and you try to convert that decimal into a fraction, if it gives you the same exact thing back, then that means that that number is irrational because there is no equivalent fraction. On our papers, if we have a question like this that is asking us to tell whether a number is rational or irrational, and we want to explain why, then all we have to do is write, well, the square root of 3 is irrational because it simply can't be written as a fraction. You don't have to go very in depth. You don't have to write a paragraph. All you have to tell me is this a rational or an irrational number, and can it be turned into a fraction or not? And now using your calculator, you can tell if any number can be written as a fraction or not. However, what if the number was actually rational? What would that look like? Well, let's say we took another decimal. Let's say that we're not evaluating anything. I'm just taking the decimal 0. Let's first do a repeating decimal. So we're going to do 0.2222222 or 0.2 with a bar on top. You're just going to put as many 2 as possible, as many 2s as you can. So you're going to put in a bunch of 2. So I have 0.22222 with a bar on top. And now I'm going to go ahead and try to convert this into a fraction. So I'm going to go again. I'm going to go to math. I'm going to go to fraction. And now it's converting that decimal that we wrote down in the calculator into a fraction. And when I press enter, I see that I get a fraction back. Since I got a fraction back, then that means that that decimal that we put into the calculator is actually rational. Okay, and I can do the same thing with a terminating decimal. Maybe it's not a decimal that repeats or a decimal that has a pattern. Let's say I want to do 0.875. Oops, that's not what I wrote. Well, let's do 0.847. Can we convert that into a fraction? So we're going to try the same thing. We're going to go to math. We're going to go to fraction. We're going to press enter, and I see that it gives me a fraction back. So in fact, that decimal is rational. As long as you get a fraction back, doesn't matter how pretty, how long, or how big the fraction is. As long as you get a fraction back, that means that the number you've put into your calculator is a rational number. So now you know how to check if a number if a number can be written into a fraction or not using your calculator. So you can take any number, whether it's a nice decimal, an ugly decimal, whether it's a square root, a repeating decimal, one with or without a pattern, put it into the calculator and check if it can be turned into a fraction or not. Now I want you to know one thing. If you ever try to put a whole number into the calculator and you want it to turn into a fraction, it'll actually just give you the same whole number back. And that's because the calculator assumes that you know that any whole number can be written as a fraction by putting a 1 under it. So just because you get the whole number back, it does not mean that it is irrational. Only when you put in a decimal and you get the same decimal back, then that means that that decimal is irrational. Whole numbers are automatically always rational.